Probability and Statistics, Permutations and Combinations, Part 1. This part actually deals with counting principle and permutations. When dealing with the occurrence of more than one event, it's important to be able to quickly determine how many possible outcomes exist. Here's an example. We have an ice cream sundae with 5 flavors of ice cream and 4 possible toppings. How many different sundaes can be made with 1 flavor of ice cream and 1 topping? So the 5 flavors across the top of the ice cream, and here are the toppings. So each of these 5 ice creams can have one of those 4 flavors. So we add 4 5 times to get 20. But it is easier to multiply 5 times 4 rather than list the entire sample space or possible combinations. We can simply multiply 5 times 4. And this multiplication process is known as the counting principle. It works when there are 2 or more activities occurring at the same time. A coin is tossed 5 times. How many arrangements of heads and tails are possible? Right, well, there are 5 places. First throw, second throw, third, fourth, fifth throw. We could get 2 possible results from the first, head or tail. We can get 2 from the second, head or tail. So the head on the first could get head or tail on the second. The tail could get head or tail on the second. So that makes 4. You take those 4, there are 2 options there, making 8. So that's the counting principle. So we just multiply the 5 2's together, 32 possible arrangements. The counting principle is simple to multiply, simply used. Multiply the number of ways each activity can occur. Let's take an example. 4 books on a shelf. How many ways can I arrange 4 books on a shelf? So let's look at the first place on the shelf. 4 options. Now we're going to look at the second place. We only have 3 books left to arrange because one's had to go to the first place. So therefore for 3, we have 3 options for the second place. 2 for the third. And 1 for the fourth. 1 for the last place. Which gives 4 times 3 times 2 times 1, 24. That has an abbreviation there, 4321. 4 exclamation mark, if we say 4 factorial, and it means 4 downwards. So n factorial is n times 1 less than n times 2 less than n times 3 less than n times 2 times 2 times 1. And that is your n factorial. Pause, try a little practice with these factorials. You do have a factorial key on your calculator as well, n factorial or x factorial. Take careful note of this 9 and that 3 factorial times 3 factorial, their answers. So 5 factorial is 20, 5 times 4 times 3 times 2 times 1. 3 factorial times 3 factorial is 6 times 6, giving you 36. 9 factorial is 9 all the way down to the 1, giving you a very different number. So please note that you cannot multiply factorials together. This next one, 7 factorial, is in fact 7 times 6 times 5 factorial, because it's 7 times 6 times 5, 4, 3, 2, 1. So the 5, 4, 3 to 1's cancelled with the 5 factorial below, leaving just 7 times 6. In the same way, n factorial is n times n minus 1 times n minus 2 downwards. Well, there's the n minus 2 downwards. So cancels, and all we have is the n minus 1. Same thing happens here with the 12 factorial, 9 factorial. So we end up with 12, 11, 10, and then we have the 3 factorial below. That arrangement earlier is called a permutation, and the important word is arrangement. The permutation is arrangement of elements of or from a set S of numbers, from a set of numbers. Now it's of or from because it could be the whole set of numbers or it could be just some of the elements, which we'll do next. So if S is ABC, CBA is a permutation of S, and BCA is a different permutation of S. Now let's put books on the shelf again, but now we have 10 books to choose from. So in the first place, instead of 4 now, we have 10 options. We had 9 options for the second place. 8 options for the third. Note each time, because one of the books is gone. It doesn't necessarily have to be that one, but I'm using that one as the example. And the fourth place, 7 options. So in fact, we have 10, 9, 8, 7, and the 6, 5, 4, 3, 2, 1 has been cancelled out. Only the 10, 9, 8, 7 left. That is called an R permutation, the permutation of R objects from N objects. So we're doing a permutation of 4 objects from 10, 4 books from 10. Here the notations used, NPR. It could be superscript N, PR. There's another one, there's another one. We'll use the first one. And NPR means N factorial over N minus R factorial. Let's illustrate from that top example. There we are. This 10, 9, 8, 7 is 10 factorial over 6 factorial, or in other words, 10 factorial over 10 minus 4 factorial. Why 10 minus 4 factorial? Because we were arranging 4 items of the 10. Means cancel the rest out. And that is 10p4 is what that arrangement of 4 books from 10. So, how many different numbers can be formed with the digits 1, 2, 3, 4, 5, where the repetition of digits are allowed and the number has 5 digits? Well, 5 digits to choose from. We can repeat digits, so each time we have 5 options. Let's draw a table. There we are. Position of digits 1, 2, 3, 4, 5, and we have 5 choices for each. And by the counting principle, we multiply them, get our answer. Next one, the number has 3 or 4 digits. Now we cannot have both 3 and 4 digits. We've got to have 3 digits, and if they're 3, then we can't have 4. If they're 4, we can't have 3. So these are mutually exclusive. And with mutually exclusive cases, we calculate the number in each and add. So, 3 digit. We're going to do mutually exclusive. 3 digit. Table, 3 places. And it's 5, 5, 5 because we're allowed to repeat. Which gives us, multiply by counting principle, 125. 4 digit, we're going to have 4 5s multiplying for the 4 places. Give you 625. And by the counting principle, I add them to get the total number. Now, what if the repetitions are not allowed? Let's go through the same question again. So same thing, 5 digits to choose from. Now it's a permutation. We're going to use permutation principles because we cannot repeat the digits. So in the table, in the different positions, we have 5, 4, 3, 2, 1. 5 digits to use for the first, but when we get to the second, we've lost a digit, so it's only 4. So we multiply by the counting principle, and 120, that's 5 factorial. Part B, let's do by mutually exclusive again. So for the 3 digit, 3 places, 5, 4, 3, we have 5 options, 4 options, 3 options, giving us 5, 4, 3, 60. That's 5p3. That's permutation, 3-digit number. We're taking 3 of the 5 digits, so it's 5p3. 4 digits, position of digits, we will have 4 places, and it's 5, 4, 3, 2, giving you 120, and that's 5p4. So the total number, we add the 2 mutually exclusive numbers to get 180. Now we're making a registration number for a car. Consists of 3 letters of the alphabet and 3 numbers. The letters of the alphabet cannot have vowels. We cannot have vowels, we're excluding them. So it means we have 21 options. There are 21 consonants as an option. Right, the options. First place, 21. Now we are not allowed to repeat. So therefore we've used 1, so it's 20 and then 19. On the side of the digits, there's nothing said about not repeating, so we can repeat them, so it's 10, 10, 10. Multiplying them by the counting principle, and there, which is 21p3, we're choosing 3 from the 21 constants, times 10 cubed. Now, B, letters may be repeated, so the only difference now, the options are all going to be 21, and they are all 10 again. So it's 21 cubed times 10 cubed. Slightly more complex number, car registration number in a province, 3 letters and 2 digits. The repetitions of letters and digits are allowed, but the O and Q and the 0 are not to be used. Now that means we can use all letters but O and Q, so we have 24 letters and we have 9 digits to use. How many registrations can be formed if there are no other restrictions? So 24 to choose from for the 3 positions of letters and 9 for the 2 for the digits. So there we are, 24, 24, 24. Part B, the first letter must be a consonant. So we place the first letter. 20 choices, because consonants, there are 21 consonants and we cannot use the Q. So number of registrations, 20 for consonants, 24 for all the letters, because it's only the first place has to be a consonant, 24 and then 9, 9. Now we need to alternate vowels and consonants. And here we have mutually exclusive, because either can start with a vowel or a consonant. If there was the same number of vowels, if there were the same number of vowels as consonants, we could do it as a single, so that's separate. But here they are not the same, so we must work out the number with vowels and the number with consonants as mutually exclusive events and then add them. So starting with the consonant, we can have 20 and then 4 vowels because we have to take the O away from the 5 vowels. 20 for the consonants, 9, 9 for the numbers. starting with the vowel. Right, so we have 4 options for the vowel, then 20 for the consonants, and so on. And we're trying to find 3 or 4-letter words. No, we're not here. Oh, we're trying to find consonant or vowel. There we are. So we add them together and we get our final answer. 10 volumes of encyclopedia are placed in any order on a bookshelf. What's the probability that volume 1 is first and volume 10 is last? Well, a reminder of a little principle: probability, number of favorable outcomes over total number of outcomes. So, number of favorable outcomes has volume 1 first and volume 10 last, because that's what we want, and the remaining 8 can be arranged. Total number of outcomes is 10 to be arranged, which is 10 factorial. So we substitute these numbers into there, and there is our probability.